Right, today we're going to talk about the area of trapezoids. From your formula sheet, we can see the area is 1/2 times the height times the quantity base 1 plus base 2. From when we talked about trapezoids, our bases are our parallel sides. Our height will be the perpendicular distance in between those bases. So even if you know what this is, that is not the height. It has to be the perpendicular distance. It's going to have to form right angles there. So if we take a look at this first example, we're going to say our bases are 10 and 15, and our height is 8. So if you have everything you need, like we do here, you can just plug that right into the formula. Your height is 8, and your bases are 10 plus 15. 10 plus 15 is 25. And now this looks a lot like the area of a rhombus. And if you watch that video, you could either multiply these together first and then divide by 2, or just take half of the first number here. And that's what I'm going to do. Half of 8 is 4. 4 times 25 would be 100 square units. So in that particular example, you had everything you needed. You could just plug right into the formula. For our next example, we have an isosceles trapezoid. That's when our two legs are congruent. And we're going to say that our legs are 8 and our bases are 10 and 15 again. So I'm using the same numbers, but I'm not going to get the same answer because up in the problem above, 8 was my height. In this particular one, I don't know what my height is. Oh, I forgot. There's one more thing I need to tell you. These base angles are 60 degrees. You might remember from when we did some problems like this using, in Chapter 8, using the Pythagorean theorem or special right triangles, that we can draw the height on either side of our trapezoid, and that's going to form two 30, 60, 90 triangles, and we can use that to find out what our height is. So we fill in our numbers there. Our 2, our 1, our square root of 3. So we're going to divide in. 8 divided by 2 is 4. And then multiply out. 4 times radical 3 would give me 4 radical 3 for the height of this trapezoid. Now that I know what my height is, I can go ahead and put all of this into our formula. 1/2 times the height times the sum of the bases. Now we do have a radical 3 in here. We are going to multiply everything that we can and then keep that square root of 3 after because it can't multiply with everything else. So I have half of 4, which is 2. 2 times 25 is 50. And I'm just going to keep that square root of 3 after. So that the area here would be 50 radical 3 units squared. All right, let's take a look here at one more example. For this particular trapezoid, it's another right trapezoid, bases of 10 and 15, and this leg over here is 13. Now again, from what we started with, we can't use 13. That's not the height of this trapezoid, so we need to work to find out what this would be. Now I can draw a height here. That would be the same length as over here, and that's going to form a right triangle on the left here. This base is 10. That would be the same distance across to here, and since this base is 15, if I take these numbers and subtract them, I'm going to get 5 for this leg in my right triangle. So I can, of course, use my Pythagorean theorem here. 5 squared plus b squared equals 13 squared. I square, I get 25 plus b squared equals 169. I'll subtract my 25 from the 169 and get 144. And then that's the square root of 144 will give me 12 as my height. So both of those would be 12. So now I have my height and both of my bases, and I'm good to go with my formula. 1/2 times 12 times 10 plus 15. Now you may have noticed I did use the 10 and the 15 for all the bases in all of these examples. Not every trapezoid will have bases of those. I just liked using those numbers today. And here we go. For this one, I have half of 12. That's going to be 6 times 25, and that would give me 150 square units.